Good morning. One of my most favorite function in computer is Control Z or the undo button. I use it most of the time because I made a lot of errors. I wish life has an undo button also. If it does, I could have taken more risks because I know I can reverse my mistakes once they are discovered. In mathematics, just like in the natural world, many operations are inverse of each other. For example, subtraction is the inverse of addition, division is the inverse of multiplication. I can list a lot of mathematical inverses, but I know you get the point. Factoring, which is our lesson for today, is the inverse operation of getting a product. So let's begin our lesson on factoring. Factoring is the process of finding what to multiply together to get an expression. It is like splitting an expression into multiple, simpler expression. And factoring also is the inverse of getting a product. Let me illustrate that this way. For example, you have the product. 3 times 4 is equal to 12. If you reverse the operation, factoring is you are given the product 12 and you are asked to find what are the factors or what are those numbers such that when you multiply them, the result is 12. And those two numbers are 3 and 4. So in algebra, when you are asked to find the factors, you are asked to find these two numbers, the multiplier and the multiplicand, or simply the factors, such that when you multiply them, you will get that given number as the product. Visually, it looks like this. When you are given a factoring problem, you are given the area, and you are asked to find what is the length of the sides. So for example, the area is 12. What are the factors of 12? The factors of 12 are this length, which is 4 units, and this width, which is 3 units. So the same concept applies when we factor algebraic expressions. There are several ways and kinds of factoring in algebra, so let's begin with the simplest one, factoring the greatest common factor. For example, you are given this problem, factor 2x plus 6. So let's begin by visualizing this first so that we can understand better what's happening when we are factoring the common factor. So I have here these manipulatives and we are going to form 2x plus 6. So we have this 2. So that is 2x and we need 6. 1, 2. We need to arrange this in such a way that we can form a rectangle. So what you have here is 2x, 1, 2. The x are these green rectangles. And you have 6, 1, 2, 3, 4, 5, 6, the yellow squares. We said that to factor 2x plus 6, or to factor the product, we need to get the length and the width. So what's the length and the width here? The length is this one, and the width is this one. So let's write them down. The width would be this 2, 1, 2. And the length is x and 1, 2, 3, x plus 3. We therefore say that the factors of 2x plus 6 is 2 times the quantity x plus 3, with 2 as one factor and x plus 3 as another factor. Now let's analyze what's happening here. Notice that if you look at 2 and 6, 2 can be written as 2 times 1, and 6 can be written as 2 times 3. Now, we need to write this in such a way that 1 and 3 are in their own column. Now, notice that 2 is the common factor between 2 and 6. And that 2 is now our common factor. To get into x plus 3, this is what you are going to do, assuming that you do not know that yet. 2x divided by 2, the 2 and the 2 are cancelled out. So what we are left with is the x. So you have the x. So we divide 2x divided by 2, 2x divided by 2. We'll be able to cancel out the 2's. So what we are left with is the x. That's the x. Then go to the next term. 6 divided by 2. We get 3. And that is the 3. So let me repeat the process. To factor the common monomial factor, first find the greatest common factors of the constants. The constants are 2 and 6, and then you do the prime factorization, get the GCF, and then that GCF is one of the factors. Once you identified that GCF, you have to divide each term. That means all the terms. When I say terms, those are that part of the expression separated by the plus or the minus sign. The plus sign is here, so 2x is one term, and 6 is another term. And then 2x divided by 2, you get this first number inside the parenthesis, which is x. 6 divided by 2, you get the second, which is 3. And then 2 times the quantity x plus 3 is now the factored form of 2x plus 6. Let's have another example. Factor 3x squared plus 12x. So you can understand this better, let's visualize them first. We need 3x squared. Remember, this is the x squared. X squared is a square with a length of x. 3x squared means we need 3 like this. So let's arrange them. This is 3x squared. And we need 12x. So let's have 12 of this. 1, 2, 3. The goal is to form a rectangle. So 3x squared plus 12x is now this one. 3x squared plus 12x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3x squared plus 12x. Now to find the factors, we need to find what is the length and the width. And the factor of this would be this length and that width. And how do we read this one? It's 3x. And how do we read this one? You have x plus 1, 2, 3, 4. X plus 4. So therefore, the factor now of 3x squared plus 12x is 3x, which is this length, and x plus 4, which is this length. So this is how we represent 3x squared plus 12x equals 3x times the quantity x plus 4. 3x squared plus 12x equals 3x, 1, 2, 3, times x plus 4, 1, 2, 3, 4. Suppose we don't have that manipulative. Let's generalize what we are observing here. When you have 3x squared plus 12x, look at the numerical coefficient. You have 3, and the factors of 3 are 1 times 3. And then you have 12, and what are the prime factorization of 12? 12 is 3 times 2 times 2. If you get the greatest common factor, the factor that's common to both 3 and 12, you will find that that greatest common factor is the 3. That becomes now your GCF. And then look at the variables. The variables are x squared and x. X squared means x times x. And x, of course, is x times 1, or simply x. If you get the greatest common factor of x squared and x, that would be x. So that's the other common factor. In other words, our greatest common factor here would be the GCF of the numerical coefficient, which is 3, and the GCF of the variables, which is x. Once we find that greatest common factor 3x, all we have to do is divide the first term here by the greatest common factor. So 3x squared divided by 3x, 3 and 3 would be cancelled out, so we are left with x squared divided by x. So when you divide x squared divided by x, that means x times x over x. We'll be able to cancel out this x, so you are left with x. That's why you have x here. We are done with the first term. We go to the second term. The second term is 12x divided by 3x. So let me write here. 12x divided by 3x. So we'll be able to cancel out the x. 12 divided by 3 is 4. So don't forget to get that operation plus, and this one, the quotient of 12x by 3x, and the answer is 4. So this would now be our factored form of 3x squared plus 12x. Visually, you can imagine in your mind that 3x squared plus 12x is this big rectangle with this one as the 3x squared, and the green ones are the 12x. And then the factors 3x times the quantity x plus 4 are the length and the width. You have 3x here, and you have x plus 4 here.